Now to start, I'll just start out with something that is fairly useful for you to understand, is that this whole picture over here is your main power supply. Okay, don't mix with what the slides had say main power supply unit. Alright, because the main power supply unit is actually this thing over here, as you can see, the main power supply unit. And the power supply unit, the PSU that we are talking, alright, is something that you're gonna tag along. Alright, if you find this familiar, this one is actually the one that you use inside your electrical lab, right? So normally this is the power supply that is supplied from your local network. Alright, from if you are in Singapore, then Singapore has its own local power supply unit. Alright, so this main power supply unit is gonna supply power into your system. Alright, and it often has its own power supply voltage. Alright, maybe some voltage, I don't know what voltage is that. Alright, maybe we say if it supply 10 volt, for example. It's not real, okay? So for example, you supply 10 volt, alright, in order for you to use, alright, you're gonna step down, alright, to something that is safer for you to use, for example 5 volt. Okay, fault. Alright, ignore what I just said. Alright, I suck. But anyway, let's take an example. If the main supply is 20 volt at 50 hertz, alright, so over here, if your main supply is 20 volt at 50 hertz, alright, in order to actually run in your system, this is not your system yet, alright, you may have to connect your system to whatever your device, your handphone or your computer and things like that. Alright, so normally this one is just the main power supply, and this one will send to a certain supply unit, alright, such that your supply unit will actually regulate the voltage to the one that you need. Alright, so in order to translate the voltage, because this is actually quite a high voltage, 20 volt, this is in Europe. Alright, in North Africa is 110 volt, alright, for about 50 hertz also. Okay, so for the North Africa is 110 volt. As you can see, it's pretty high. Alright, so different country has different main power supply. So therefore, you require a certain power supply unit to actually regulate, or you're gonna regulate the voltage so that your smaller system can use. Alright, so this is something that, if you remember, if normally when you play with your electrical system in the lab, alright, you normally connect your component into a certain power supply, correct? So this is the same thing, because this thing over here, it helps you to regulate your voltage so that your other smaller components can use and tap in the voltage that is required, so you will not short circuit your system or destroy your machine or whatever. Alright, so this thing over here is your power supply unit, or your PSU. Okay, this is what is trying to say. Alright, it's your power supply unit. Okay, but nonetheless, alright, you may also contain this power supply unit within your own machine. So this thing over here is within your own machine. So this whole machine is machine A. So you have other components like motor, like other stuff, alright, other little small stuff. So it's straight away you can tap into the main power. Alright, you can tap into the main power, take in the voltage, you regulate, you output to your whatever motor that you want. You can also do that. Alright, so there is many ways of implementing your stuff, but this is called the power supply unit. Alright, and this big chunk of stuff that I've been talking about is called the linear. Alright, linear system, the classical approach with transformer, rectifier, everything japalang, all time inside only, just whack only. So that's why it's very bulky, as you can see. It's very big, but it's pretty good because it can regulate a quiet electrical system. Alright, why is it quiet? It's because it's not that it doesn't make sound, but it's in terms of a very clean noise. Alright, there's no as you can see, this thing over here is your power supply unit. Right, the one that I'll just show you, the big huge bulky stuff, this one over here. Alright, it is actually very clean. You see the signal over here, 5 volt linear. It's very nice. Alright, but however, if you were to go into the next one that I'm now gonna say, is called switching. switching itself, as you can see, there's a lot of noise going on. Alright, but it depends on the purpose. Alright, therefore it goes to the purpose of whether do you want a noise or whatever things. Alright, so if you want a very fine-tuned voltage, you can use the power supply unit, but it limits. Alright, it limits your portability. Alright, on the other hand, like switching, alright, this is another method. Alright, so besides this one, alright, this is another method. I mean, we will have another method. Alright, so what is another method? We call the switching, right? So I'll just link it up. Alright, so this switching is macam like your power, your battery charger, alright, for your laptop. Alright, same thing. Alright, the battery charger, as you can see, this big chunk over here, if I were to highlight in red color, alright, this big chunk over here, this piece helps you to bring down the voltage. For example, 20 volt, it helps you to bring down to the voltage that your laptop can use. Alright, so this is your laptop. Alright, so if imagine you set a 20 volt, your laptop only use 5 volt. Alright, this charger over here helps you to regulate it such that the 20 volt becomes 5 volt, then your 5 volt laptop can use. Alright, this is the method of using this. Nonetheless, you can also connect your this thing over here to a power supply unit. Alright, you see, you can have different way. So you don't need the charger actually. If you can also have this thing to set to bring it to your laptop. You can also do it. Alright, so these are the two sources of power that you can use. I mean, in terms of a supply unit, okay, or power supply unit. Okay, so this thing over here is your linear power supply unit. This thing over here is your switching power supply unit. Alright, so hopefully this gives you a good concept of what exactly is the power supply unit. Alright, but nonetheless leave room that I may be wrong. Okay, so therefore, as you can see, a switching system is give a much smaller, lighter and more efficient product. Alright, like your battery charger. Alright, however, they produce a lot of electrical noise. Well, as you can see, there's a lot of spikes all over here. Over here, this is very clean, very nice, one straight line. Alright, so therefore it depends on which one you really need. Alright, if you need just to charge your laptop, then you can just use this one. It's simple. If you want something that is talking about fine-tuning your electrical musical stuff or things like that, I think this will be better. Things like that. Okay, I don't know, leave you to think about it. But at least this gives you a good concept of the supplies. And now, haven't finished yet, we'll talk about the features of the main supply. Alright, which is the supply, our power supply unit. Alright, this, I think this two lah. Alright, that's why the main word makes me feel a bit but up till now I don't even know, is this they're talking about the main supply, the one that I've just told you, which is this one, or are they talking about the supply unit, this one? Alright, I'll leave you to think about it, but we'll just briefly go through. Is that features of main supplies, or is that it's readily available in your buildings, but it limits your portability. Alright, so I think this type of thing is within your system. I think normally in your HDB flat, alright, HDB flat normally will have something like this, alright, and then you have some switches over here. Alright, so I think this one is your power supply, your power supply unit. Alright, so over here this one is very similar to this one. Alright, you have your chapalang, everything inside, your capacitor, your whatever thing. Alright, so this thing over here is like your power supply unit, the linear one. Okay, so this, I think this is what they're trying to say. So this thing over here, alright, we're going to supply voltage into here, and this one over here we're going to supply voltage into your household. Alright, whatever thing, your kitchen pot or whatever. Alright, so you can actually tap into your plug. Alright, there's a plug over here, so you can actually use it. Things like that. Alright, nonetheless I may still be wrong, but this is what I know. I'll just write down first. So the cost wise is power from the main is virtually free. I don't know why, but compared with batteries, 10 to 20 pennies per kilowatts, even allowing for loss in the PSU. So I think from what he's trying to say is that this thing over here is a much more better cost effective system than your battery. Alright, not this battery, this is not a battery, this is a battery charger. Alright, so battery is similarly like your AA battery and whatever thing, because AA battery, if you think about it, for example 1.5 volt, alright, you supply 1.5 volt, you can only power up certain stuff, and each of this battery costs quite a few dollars compared to your power supply unit. Alright, it can supply a hell lot of voltage. Alright, because you can see 20 volt from your power supply unit, whatever, or your main power. Alright, so you can actually step down or whatever, or regulate your voltage and whatever. You can actually use a lot of power in a less cheaper way. In a more cheaper way. Yeah, so this method over here is somewhat cheaper than buying a battery. Think about it. Right, this battery has a limitation of voltage. This one over here has no limitation. You can use whatever you want. And if you compare it, normally your bill, alright, electrical bills normally, for example, normally monthly is about $23.50. Okay, so if you were to buy, for example, this AA battery, this maybe you buy one pack, alright, four batteries, $1. Alright, you buy for example 100 batteries, they're gonna cost about $25, for example. So you need 100 batteries to run all your household for 1 month. Do you think it's sufficient or not? You have washing machine, you have you have your vacuum cleaner, you have your microwave, everything. Do you think this 1.5 volt can help you to supply enough power to your system? No. But however, having this thing over here, you can actually run everything in such of a cheap cost, you see. So these are the things that you may also want to consider, or these are the things that you may also want to know. Alright, and next one is generally reliable. Alright, because it doesn't run out of like batteries, right? And power cuts are not often very frequent. Alright, so nonetheless, if your power cuts are unknown, or in this case they say the power cuts are unknown, alright, then you requires a backup supply. Alright, so in other words, generally reliable because it rarely have power cuts. So if have power cuts, normally will requires a backup supply. So this is something for you to know also. So normally when you have a power supply unit, alright, this type or this type, normally you require a backup, so that if anything wrong, you can actually have a backup power supply to additional one. Alright, one more, and then one more of the supply unit, so that you can supply to whatever thing that you want. At least you will not run out of batteries. I mean, at least you will not run out of power and things like that. Okay, and over here it says that you may also wish to retain the data or keep the clock calendar chip. So within the computer itself, you have a certain clock calendar. If you remember, normally when you open up your computer, your clock is always the same. You don't need to reset your own clock, right? Normally when you on the computer, straight away the clock is like this, happy, right? But however, without this is all talking about this clock calendar chip. If you don't have this chip, then normally every time you on this computer, you're gonna reset everything, right? Correct. So therefore this chip over here is for that purpose. And so therefore you have a very small backup power supply to actually power up your calendar chip. Alright, so I think this what they're trying to say is that this small backup system, alright, is backup, alright, to help you retain data or retain a very small amount of data, or because comparatively trying to code this clock over here, it requires not very much of a power, right? It's just a few power, that's all. Okay, so therefore in this case, this backup actually help you to power up your little small peripheral understandings, or peripheral or like a 旁边菜 of type of system. Alright, so this thing over here is like a side dish, or something that is not important but is something that you still require. Alright, so therefore you normally you have a small backup to actually back up this type of chip. Alright, so it continues to run even when your equipment is switched off. So this is in computers lah. So what I've been talking about is this meaning lah. Okay, So for the power supply unit or your power supply unit, alright, you can help to reduce the noise. Alright, the noise is the transient pauses from heavy equipment switching on and off. For example, in your building, alright, this is the main supply. Alright, so normally when it on or off, alright, you're gonna have a very huge power surges, meaning you have a very huge power surges, and then it eventually goes like this. Alright, so over here this is in terms of a very high power. Alright, so in order to actually regulate because your this thing over here, or your power supply unit in your house over here, is keep on tapping in power. So if you have a certain surges over here, alright, then this thing over here gonna take in the amount of power over here. Correct? So this amount of big power will actually short circuit a lot of stuff. So therefore this thing over here act as a regulator also, to regulate this type of surges, so that you can actually prevent anything from spoiling your stuff and things like that. Okay, so therefore the PSU must filter this out. Alright, it's gonna filter all these transient pulses out. Alright, but nonetheless, in most extreme cases, lightning strike or major failures of the distribution system can cause surges also. I don't know, but yeah, like lightning strike, everything will also cause this type of surges lah. So your power supply unit must be able to filter all this thing out. Alright, so lastly, will there be problems if the equipment is used in other country? Alright, if you have a power supply unit, alright, you can actually regulate your voltage. So definitely your equipment can be still used in within other country. It's because you have a regulator. You think about it, if you were to happen that you bring your laptop from Singapore, you go to other country, you can still use other country power to power up your laptop, right? You can still use other countries' power to charge your laptop because of this power supply unit. Alright, just to recap, this is actually called the switching power supply unit because it's very small in size, portable, which is this one. Okay, when you charge your laptop, you wouldn't bring this linear power supply out, right? You wouldn't bring this huge chunk of stuff inside your plane and then you supply power to your system. Don't, right? Never, right? So therefore, normally you have this portable charger, alright, to help you to charge your battery, whatever. So this portable is like a power supply unit to regulate your voltage to whatever thing that you really need. Alright, so therefore it is still safe. Alright, just to answer the question, there will be no problem, alright, because you have your power supply unit. As long as you have this thing over here, you are always safe. Alright, so in the next part we'll talk about battery, but before I go into the battery, I'll just calculate a few things about the cost. Alright, you see, talk about the board very cheaply and things like that. I'm going to talk about the cost, the calculation of the cost in case that you may need. Alright, see you then.